Oh! Have you ever gotten a warning like that and wondered why? Well, then this video is for you. Today we're going to learn about the differences between copy versus slice, and you're also going to learn when to use the copy and when to use the slice. If you don't know which one to use, you're probably going to end up messing up some analysis at your job, and that's something that I've done myself. And if you want to reduce the risk of making these mistakes, please check out this video. Here we are again, and let's get started by importing our library, Pandas. This is the only library that we will need today, and we're also going to need a data frame. I'm just going to copy and paste it in here. You'll find the link in the description. So let me have a look at the data frame here, so we can see that we have a very dramatic data frame for a not so dramatic topic. So we have conflict and crisis throughout the history of our existence. No, not our existence, but human existence. So we have the event here. What type of event was it? Was it a pandemic, internal conflict, famine, or war? We have when did this happen? Where did it happen? How many people estimated to have died? And how many percent of the world population was that specific death toll? Well, we can also look at the df info method here, and we can see that we don't have that many null values, just 2 missing values on floating point columns here. So we only have 2 missing values for 2 columns here. And without further ado, let's move into slice versus copy and dealing with this setting with copy warning that you might have seen or might have encountered while using Pandas. So it's really important to know the difference between a slice and a copy. A slice can also be called a view. So if you're playing around and making changes to a subset of a data frame, and you don't want these changes to modify the original data frame, then what you should go for is the copy method. Then you should create a copy. On the other hand, if you just want to create and access subsets of your data and viewing them without modifying them, then slicing is the most suitable option for memory reasons. And if you're uncertain of whether to use copy or slice, it's a good heuristic to always go for the copy. It's generally safer, and you will safeguard against errors and unwanted modifications. So what is a slice? Well, I'll show you what a slice is. So a slice is just a subset of a data frame when you get the subset to look like this. So it could be either that I'm selecting something with the lock method. It could also be that I'm just selecting a column. So basically what I'm doing here right now is that I'm slicing a column, right? And now I have the slice here. So I run it. It's a series, all right? And the series is containing numbers on the numbers of death depending on the catastrophe. So the last one is COVID, and this value needs to be updated because the current death toll on COVID is actually 6.9 million people. So I'm going to update that. And how do we update values? Maybe you know that we would use the lock method. So I'll say, okay, I want to update this specific data frame now, or this specific series right now. So I'm saying index 36. Okay, I get that value, and now I just simply say, okay, I want to set this to 6.9 now. Run that, and now I get the warning. And also remember, a warning is not an error, so that it actually does make a change. It's actually something happens here. But the problem is not if I look at the slice. The problem is if I look at the data frame. So we can see I managed to change this to 6.9, which is what I intended to do. However, if I look at the data frame, I'm also changing the data frame. So why is that? When we slice data, we do not create a new object in our memory. We are just getting a view of the original data frame. So when we make changes to the slice, we are actually changing the original data frame object. So the solution to this problem is just to create a copy, because then we're going to create a new object in the memory of our computer. So the copy will look basically just like the slice did, but we're adding this copy method afterwards. Boom, like this. And now if I try to change, we can have a look at the copy. It says 6.9 here. So I'm gonna change this to 7 now so we can see the changes. So I'm gonna say this 6.9. Now it should be equal to 7.0. All right. The copy, we can have a look at it. We can see here it's been changed to 7. But if I look at the data frame, nothing has changed here from the copy, right? So when I'm using a copy, I'm just changing this. It's not going to affect the original data frame. Okay, so that's part 1. Then there are going to be cases when you're going to make, when you might make changes to the original data frame without receiving the warning. So one example of that would be if I would say, well, so we have this the slice here, right? So we have 2 missing values in the slice, and let's just say for the sake of this example that I want to fill the missing values with the average of the whole column. All right, so this is the average. I'm gonna round it, and I am gonna call it mean value. Save that. Now I am going to fill the slice. I'm going to fill the missing values with the mean value here, and then I will in place it. See what happens. It works perfectly at first glance. But if we look at the slice, you can see that 19 has been imputed here and here. So now the problem is that, yeah, okay, it was also imputed here, and that's what we wanted to avoid. We only wanted to make changes to our subset. So how do we avoid this? Well, basically it is the same. So let's select this column now, and we're gonna call it the copy, and I'm gonna add the copy here afterwards, like that. And then we have missing values here that they also need to impute, so I'm gonna do the same example. So I'm gonna say mean value is equal to the copy dot mean. I'm also gonna round it, and then I'm going to fill the copy with my mean value, and it's going to be in place equals true. Now if I look at the copy, you can see that we successfully changed the values here, and if we look at the data frame, we can see that the values didn't change, right? So we have NaNs and NaNs, and here we have 3 and 3. Okay, now on to the last topic, which is how we can avoid chained indexing. So let's have a look at the event column, and let's go down to the 1918 flu, which is also known as the Spanish flu. So I want to rename this to be called the Spanish flu, and I'll show you what the chained indexing is. So chained indexing is when you put index on top of each other. So first I'm indexing the column event, and then I'm indexing the row 24, right? So this is one way of creating a chained index. So the first I'm getting the column index, and then afterwards I'm in a new notation, I'm getting the row index. If I say that this should be equal to Spanish flu, when I run it, I'm gonna get this warning again. I could also do it from the other way. I think this is pretty common to see. I see this very often with my students, that they do something down these lines, so they get row 24, good, then they want the event, and then they're using the lock method, which is good to use the lock method, and then they want to change it to the Spanish flu. And in this case, we also get a warning. How do we do this the correct way? Well, so how do we do this in the correct way? How do we avoid chained indexing? Well, we're going to use the lock method, and we're going to index this value in the same notation. So we're going to say locate, and then first we're going to get the row number, then we're going to select the column. We're not chaining methods on top of each other here. We're doing it all in one go, and that's the way to go. So I'm gonna rename this to Great Influenza Epidemic. Okay, so I think the key takeaway here is to always use lock or iLock when you're updating values on a data frame, so you'll avoid this warning. Alright, that was it for this video. I hope you liked it. If you did, subscribe to this channel because I'm gonna upload some more content for you all.